Well, it's very convenient. No, benefit from the air. How are you?
Not good actually.
Good? Yeah.
Yeah, I just finished all the deadline last week. So,
Right. And have you got any exams?
No exam.
Okay.
All the things is coding.
Right.
Uh-huh.
And it's all done?
Yeah, all things is done.
Right, so 100% project now.
Yeah.
So, let me see. You're the one, that's right, calibrating the performance. That's
Yeah,
right.
yeah.
Yes, I'm trying to remember. So, do you remember anything about it?
Actually, as my plan, this period, I should find some model and analyze them and try to understand them. Maybe I can use them in my project. I read some papers and actually, as I got the model, most of them is quite similar.
Did I send you my spreadsheet which has my model in it?
Yeah, of course.
I did. Oh, okay.
Yeah.
I couldn't remember. Yeah. I actually have it programmed on as an app. It's not a proper app, but it's separately as a piece of code in a language called Pure Data.
Okay.
It's not calibrated at all, though. It just functions.
Okay.
But, if you're interested in that, I can also send you that.
Okay. About the model, I have 3 models now. One is from your paper, and another 2 is from other papers.
Okay.
This one is I think is the most popular one.
Most
popular.
popular.
Yeah. I think
it's unpopular.
Yeah, maybe just because it's simple to do this thing. Just and I think those 2 is quite similar. About your model.
So this one is calculating the words per minute, allowing for errors. Does this do the same?
Yeah. About your model, you just add the error time to the whole time.
Yes.
And about this model, it just reduces the error words. So I think just quite similar thing.
Say that again.
About this part, all the string length reduce the error length and divide the whole time.
So what's that, by the way? Is that S?
S is no, it's 5.
5.
5. Sorry.
Okay.
So it means.
So if you have 10 entries and 2 errors,
yeah.
So that would be 2. That would be 2. So this would be 0.
No. This part is for words.
Yeah.
Words.
What's this?
This is string, and he think general English words have 5. 5. How to say? So the string divide 5 means maybe they have.
So that's the number of words.
Yeah, number of words. So
if that's 10.
10 words. No.
And with 2 errors.
Yeah.
That's 8 over something.
So for example,
yeah, I see. So it's 8 correct words per unit time. I see.
I think just a little same with those 2 models.
Yeah.
Another one is for a long model. At this model, he put the arrow directly. It has different arrows. For example, it have incorrect fixed. For means this words I input a wrong word, but I didn't change it, and some wrong words I change it. It means incorrect fixed, and some is not fixed, and also you delete some words. So the delete words means called fix. So different type have different rates.
Yeah.
This
I'm actually still thinking about the other one. I'm still thinking about this. Because the point here is, if you, so this is how long it takes to have a 100%. Assumes you correct all the errors. So these people are saying, if you don't correct the errors, so this doesn't work then. This doesn't work because if it takes a long time to correct an error, that has no effect here. Whereas here, it slows you down, as it should. So the time goes down if you spend time correcting errors. Here, nothing changes if you spend.
Yeah.
So that's not a complete model.
Yeah.
So that's not the same.
Yeah.
So now these guys, they are distinguishing between fixing and not fixing an error.
Yeah.
Okay, so that's interesting. Whereas in my model, I assume that all errors are fixed.
Yeah.
But it might take a long time. So so that seems like that's adding a bit more information. It's also adding a bit of complexity because how do we know how many errors people typically fix? We need to have a number for that.
Yeah.
Maybe in this paper they have some numbers.
Yeah. He record a list. All the people do the things he recorded.
Yeah. So he's measuring what people are actually doing.
Yeah.
I'm glad you're keeping notes. Loose leaf is not the best idea compared to having an actual book.
Okay.
But you probably should write somewhere here where you're getting this information from, because eventually you'll forget. And so you need to know which paper this was in, so you want to write something helpful. Because when you've got a big wad of notes and you're looking back 2 months, you think, where did this come from? And when you write your dissertation, obviously you have to explain.
Yeah.
So, But anyway, okay, so you're finding some different ways. This is good, this is stuff you can write about. And then in your model, in your implementation, you will select the one which seems to be the best. Which could still be the one I already used, but let's see.
Actually, I have one question about the models. At my project, there will be different input way.
Oh yes, we had the Swift swipe.
Yeah.
Thing, yes.
And should every type of the input way use the same model?
No.
If different type use different model, how could we compare them?
Well, so in my paper, there were two models. One to do with typing, and another model was to do with, sorry, one was I'm trying to remember. There's that one. There was another one which was using the size of buttons, because the speed you can type is a function of how many buttons there are and how big they are. And that so for entering words on a keyboard is a different model from speaking words, because when you enter words on a keyboard you don't type a whole word, you have to type all the letters.
Yeah.
And so if you've got a keyboard this big, that takes a long time.
Yeah.
And if you've got a tiny one, you can be fast, but you can make more errors because it's tiny.
Yeah.
So that was Fitts' law. Do you remember reading about? So Fitts' law
Yeah.
is a model of that. So that only applies to particular types of input. But the model is used to predict correct words per minute. So that can be compared directly with a different model for a different input, which is also predicting correct words per minute. So as long as they're predicting the same measure, then yes, they can be compared. But they would have to be different. So I mean, this swipe thing, I actually don't know much about it.
I try to find is there anyone to research about it, but no. No one gave a paper say how is fast, how is.
Wow, I'm surprised.
Yes.
Yeah, okay.
And during doing these things, I also found another input way. It's quite the same with swipe. It's named Airview. I don't know how to read Airview. Maybe.
Okay.
This one is just for Chinese input. It's quite the same with swipe because input with.
So tell me about swipe then. How does it work?
It's just for example, you want to input study.
Yeah.
So the first one is S.
Yeah.
So you click S and choose T. You shouldn't
So you
leave the screen. Just click on the screen.
So you're going to pass over other letters.
Yeah. And the swing will help you choose the right words. They said they have 14 million words, so they can help you choose the right words to find what you want to write.
Okay, so I'm surprised nobody has done a study on how effective it is.
Actually, I never see anyone use the swipe.
Amazing. So I mean that leads to some possibilities. You could forget it.
Okay.
I mean, you can report that you couldn't find any data, and therefore not take that further, or you could do an experiment to collect some data and try to model it.
Okay.
That could be interesting. It's not exactly the main aim of the project, but it could be a nice result.
Okay.
We'd have to consider that in the planning, whether it can fit in. Anything that involves experiments takes time, of course, because you have to have people and.
So you mean about the data? I just found the data from other papers. I just thought, actually, I thought I should do some thing to get the data. For example, to find some local people to do the. I think I thought it's on our plan, or you don't mean that.
No, you might. So there's several reasons for collecting, doing an experiment with real people.
Okay.
It could be that you want to calibrate a model, which is what we're just talking about.
Okay.
So you could imagine a model for swipe, but you don't know what the settings are, so you want to calibrate it. So you want to find out how accurate people are or something. So that would be calibrating the model. But then when you have your models, you'll be making some, and it's calibrated on the data from out there on how well systems work, like speech recognition. I mean, you're not going to build a speech recognizer, right? You're going to take from some scientific papers the results and use that. But then when you have your models, you could make some predictions, and then you could just say, well, like I do, my model predicts that speech recognition would be better than, well, no, when I published it, my model showed that typing was still very good. But that's just a prediction. So you could actually run an experiment to prove that, to test the predictions. So there's two possibilities: collecting data to calibrate a model, or testing the predictions of the model with people. So either of those are possible. Depends on the planning. Fitting it in, time takes time. But it makes for a better project, of course, because there's more to report. You'd have to design the experiment. You have to decide how many people you need. One is obviously not enough. What about 1,000? That's probably too many. Right? There's some number which you can. It's not based on pragmatics. It's based on statistics. How many do you need to prove your result? And organising them takes time. The volunteers list. Do they do it remotely, or do you bring them into a lab? If it's in a lab, you have to timetable. If they do it remotely, you have to set up a web page. Time. So this is all. We talk about it, we plan it, and then see, can we fit this in? Okay, or is it? If you come up with a plan which is too long and it's impossible to implement, you can write about it and say, so this dissertation has produced a plan. There's no time in this project to do it, but here is the plan. The next student next year could actually follow this plan. It's a deliverable. So it's not wasted time if you design an experiment, but you can't run it because of time. It's not a waste of time. It's a good thing.
Okay.
So you have a Gantt chart already?
Yeah.
We probably need to look at that again.
Okay.
Because it's probably very vague right now.
At this part, there are not two subtitle.
No.
Just
Main names.
yeah.
Of course, I can't read this. Where are we?
Here. Here.
Right, that's quite short for designing expert. But anyway, yeah. So you're finished finding models? That's what this says.
Yeah. Actually,
In fact, you marked it as
yeah.
finished. Analyzing models, you marked as finished. Is that true?
I do this maybe 3 or 4 days ago. At that time, I think maybe I finished to find models, but I do more work tomorrow, yesterday. Maybe I can do more work at this part. So
This is the kind of foundation for everything. So it's important that you know that you have found everything you can. It would be obviously bad if you later you discovered something that, if only I saw that earlier. So there's no harm extending these a little bit, just to give you a bit more time.
okay.
I'll tell you what's the high level. You're IS, or which are you in this department? Or you IS?
SSIT.
You're SSIT.
Yeah.
Okay. Yeah, we have all these different categories. Yeah. So you're in our department, but you're SSIT. Okay. But so the report eventually is background, literature survey, requirements and analysis, design, implementation, testing. So you could use those if you look at what's required. You might find those headings a bit more helpful because some of these things are like underneath some of those.
Okay.
But those are the big ones. So the reason I say that is there's the background information where you're finding out stuff. But then the next important one is requirements. So that's when you put to me, I'm your customer, you put to me, do you want this or do you want that? And I will have to make a decision. Okay, so that's a requirements capture. And so that will so you are going to be, do you know what I want in the end? That's a rhetorical question. Are you sure?
A report.
Yeah, but what result am I looking for? What do I want? No, it's written in my original specification. Okay, but you need to be checking. Okay, well, when it says you want to be able to do this, what exactly do you mean? So you want to be exactly sure what you're delivering, and then you design the whole plan to be sure that you're arriving at the point at the end, which I require. This at the moment is a bit bottom up. It's I'll do some experiments. I don't know what they are, but I'm going to do them. You see what I mean?
Yeah.
It needs to be driven by requirements, and that's kind of missing. So if you look at the structure of a report, those big headings, put them in here, and fit these as subtasks in the right place. And then you probably find it all starts to make a bit more sense and become more practical. You remember, I think, when I described planning, this is always wrong, except at the end, when you've done it. And this is here not just so you can say, yes, I've got a Gantt chart. This is here to help you. Right, so it's important to get it right. And it's to help you can understand the logic of everything. And understand why you're doing things and why you're doing it. And then when you get this starts to become more correct, it starts to really be more like the reality. You can relax because you know you can just follow the plan. Yeah? At the moment, lots of things are undecided because you haven't got things in here to cross-check and make sure what I want is what you're going to do and things like that. So that's more. It's just more about the process, how to run a project. Okay, good. So I will start to see you more regularly now, I suppose. So I'm hopefully we'll have a holiday at some point this summer, but I have nothing planned right now. That's my wife who's complaining. But I will be here most of June.
June. Okay.
I should be here. So please, book up. The slots are available, I think, for most of June. And what we want is to get you to the point where when I do go away for a holiday, it doesn't matter to you. By then you should know exactly what you're doing. And I come back and everything's fantastic.
Okay. Okay.
Yeah. All right. Good. So there are plenty of slots for next week. So I'll see you next week.
Okay.
So next week I'd quite like to see what we just discussed.
Okay.
A better,
A new Gantt chart.
upgraded Gantt chart, improved Gantt chart.
Next week. Could we have a meeting at the Monday?
You'll have to look at my bookings.
And I check it. The nearest day is Tuesday.
I think that's because I'm probably not here on Monday.
Okay.
Sorry.
Because maybe I will leave UK from Tuesday.
Oh.
So how about that? When I finish this new Gantt chart and the new work, I email you.
Yeah.
If
So what are you going back home for?
Yeah.
How long for?
go back home.
How long?
2 weeks.
Okay.
2 weeks. Because Chinese traditional. 1 month ago, my grandpa is gone, and I should bike at the something.
Yeah. Okay. All right. Well. I'm not here Friday, and I'm not. The next time I'm here, before Tuesday, is this Thursday, in 2 days.
This is Thursday.
Well, I have no slots, but we can make a special arrangement.
Okay.
But,
This Thursday.
but it's only 2 days.
2 days. 2 days I can finish the Gantt chart, but more things I'm not sure.
No. Do you want to make an arrangement for Thursday?
If we can't meet next week, this Thursday is okay for me.
Well, we certainly can't make Monday, and if you're going Tuesday, then...
Okay.
So let's book a private thing for Thursday at... today. Right. 2 o'clock?
It's
Yeah.
R-E-N. Yeah, yeah.
I was completely forgetting that. Right, and now I have to copy that across. There we go. Okay, you can see I'm at another meeting right up to it, which is in the Diamond, so if I'm not here it means I'm coming from the Diamond.
Okay. Okay. Thank you.
Okay, Vic.
Okay, bye-bye.
Nice to see you. Bye bye. See you Thursday.